Good morning. Talk about directed angles. I think this is mostly a review. Directed angles. So direction is important. How do we designate the direction of the angle? Okay. And what is an angle? All right, we're going to start real basics here. What does an angle do? An angle does what is an angle? What does it do? Okay, like area is a measure of two-dimensional space. Volume measures three-dimensional space. What does an angle do? All right. Well, an angle is a measure of turn, how far you're turning. Turn. Okay, so if you're going to turn all the way around, if I was facing one direction, I spun all the way around, how far did I turn? Well, we measure, one way we measure angles, later we'll do radians, but now we're going to stick with angles. So one full turn is how many degrees if I turn all the way around and face back the same way I was facing. So I was facing this way, I turn all the way around, that's a full turn is. I think this comes from the Babylonians. They loved angles and they loved, so this is pretty ancient, and they loved multiples of 60. Because you'll see you can divide it into a whole lot of whole numbers. Yeah, like half. You can divide it by half, of course. So if I turn halfway around, so if I'm facing, well, let's go with, we're always going to be turning from the positive x-axis, and I turn halfway around, I'm facing down the negative x-axis now, I will turn a half a turn, 180 degrees. Okay, and what if I turned half of a half? So I just turned, and I'm facing, I'm looking out the positive x-axis, I turn a quarter of a turn, half of a half, I turn how far? A right angle is, okay, just a little review, and we'll break those down further into more variables. Okay, and so that's angles. Direction. In this little directed angle system, how do we signify which direction we want to turn? Like over here, I was always turning to my left, I guess you'd say. I was turning counterclockwise, anti-clockwise. All right. Well, that is the positive direction. You might remember that. And we can also use negative. Just like which way are you going on a number line? Well, if you're going to the right, that's a positive direction. If you want to signify that you're going to the left, you use negative. Okay. So with this little directed angle system, just going to do the basics because I think definitions are very important, and just getting this, it's a system. Everything in math has a little system, and we got to agree to certain rules. So in this system, we always start, got the old coordinate plane here, right? You got positive x-axis, positive y, negative x, x going to negative and y going negative, okay? So in this little system, with this directed angles, we always start on the positive x-axis. Positive x-axis. Okay? And so then we're talking about direction. So when we rise from the x-axis, say we're going to turn 120 degrees, okay? So I'm going to start here, say point A, and I want to rotate, and there's point O, the origin. I want to rotate 120 degrees, there's 90, I'd go past 90 by 30 more degrees. That's positive, right? So this would be positive 120 degrees. It's the way we communicate. How far did to get from ray OA to ray OB, I turn 120 degrees, positive 120 degrees. So when we rise, that's the way I remember it. You're rising from the positive x-axis, you're rising like the sun rising in the morning, angle is positive. And so if we rotate the other direction clockwise and starting over here, so I've got whatever ray OD, and I want to go negative 120 degrees. So I'd go negative, that's negative 120 degrees, as I turned, the angle is negative, okay? So there's some definitions. Okay, now we'll just jump straight to an example problem. I've already gone too long on this. Maybe I'll start this video over. So there's all our definitions, and I'll go with a second video because this one got too long. And here's your directed angles problems, okay? And that's what I'll do the second video on.